Hello everyone. Today we are going to learn about Dyne Test. So here what you see is we have two sets of markers, and this is the first set, and you have a second set here, and it says the numbers right here from 30 to 44. So what I have is I have markers with the specific surface energy or surface tension of ink. So you see here it says 30 dynes per centimeter, right? So that is the surface tension of the ink, and I have second set which goes from 46 to 60. So in short, I have dyne levels of ink from 30 to 60 dynes per centimeter, and these are appropriate for plastic. In general, we can go up to 100, and materials generally they have surface tension between 80 to 100, but plastics most of the plastics that we use in packaging between 30 to 60, we can test the majority of them. So we are gonna do the testing. We have LDP plastic here. So I'm gonna test LDP plastic first. So I am expecting, based on my understanding, I'm expecting it to be having surface tension of the material between 30 to 45. So we don't have to go to like very high number. So let's do, starting from, I have 44 here. So let's do low density polyethylene testing starting from 44 dynes. So what I'm doing is, first I'm writing dyne numbers, and in front of the dyne numbers I'll try to draw a line, and we will see how it behaves. So we have markers up to 30. So what we need to do is, in front of this line, let's take first 44, that's right here, and I have this dyne marker. So I'm first dabbing, and then I'm trying to draw a line, and you can see the line beats down, and the ink kind of what's the best way to say that, ink is shrinking, right? And it's not completely wetting all the surface, so line does not stay as a line. We are losing it from certain areas, and it's turning into dots. So that's telling me it's not properly wetting. So let's go to lower number now. So after 44, now we have 42. So again, we'll first saturate the tip, and then we'll try to draw a line. And you can see it's also disappearing. So we'll wait for 2 seconds and then see how it does. And you can see it's not wetting the surface properly. The line shrinked again. So we'll keep doing this thing up to 30 dynes per centimeter, and we'll see how it does. And you can see it quickly disappeared, right? So that is indicating it's not wetting the surface. So now let's go to lower level 38. And you can see this ink also did shrink right here. Let's go to lower level again, 36. And it did not work either. So 34 also did not work. Let's go to 32. And you can see the line survived to a certain degree, and it lasted a little longer. So now we have 30 dynes per centimeter, and you can see it worked better than all the inks that I have used. So this particular ink, around 30 dynes per centimeter, is able to wet the surface. What that means is the surface energy of the ink and the plastic is almost the same. Now, if I use any ink below 30 dynes per centimeter, it's going to work from here on. So from this test, I can tell my wettability of this plastic, my surface energy of this plastic, or surface tension of this plastic is between 30 and 32. So now the second test that we are doing, it is with the PET thick sheet that we have, which generally we use for thermoforming. So PET has really high surface energy or surface dyne number, and we have numbers between 30 to 60. So we'll start with 60 and we'll go down and we'll see what we find. So I'm starting with 60, 58, 56, 54, 52, 50, 48, 46, 44, 42, 40. Now, why am I expecting higher number in the case of PET? Because I know it is a polar plastic, polar polymer. So that's why I am expecting higher number. So let's start with 60 and let's see what happens. So I have here 60 dynes per centimeter ink. So you see it actually did beat down and it did shrink. So it's not able to do as good as a job. And now I am going to 58. Let's do now 56. It's able to do better than 58, and it lasted a little longer. But we are looking for a better wettability. It should last for multiple seconds at least. 54 is doing somewhat okay. Now let's do 52. And you can, I think I'll go a little lower than this as well. The wettability is definitely improving, but I want to see if I can find a better performance. And let's go to 44. Now, you can see some of these inks, they are able to survive, so they are not beating down or shrinking. Now you can see some of these higher dyne numbers, they are able to wet the ink right here, but some of these numbers like 48 did not work as nicely. The ink did not last, the line did not last. So one thing I wanted to mention, that ink has a certain shelf life, and you can see right here it says expiration August 5, 2019. So this ink is not completely reliable. So I was expecting dyne number somewhere upwards of 50, 54 or something. It's still giving you a good idea to test. There is a critical surface tension of the ink and the substrate. If the surface tension of ink is below the surface tension of substrate, it is going to work nicely. So in the case of PET, I'm expecting number in 50s. So it should be able to, anything below should be able to work pretty nicely with this ink. Let's do one more, which is polypropylene. Now, polypropylene is, remember, it is a polyolefin family. And in the case of polyolefin family, you have just carbons and hydrogens, so no polarity. So I'm expecting a number which is somewhat similar to polyethylene. So that means, remember, we just did polyethylene a little while ago, and we were getting a number between 30 and 32. So let's do polypropylene, and we are going to start from, as we did with polyethylene, 44. So let's go downwards, 44, 42, 40, and then we have 38, 36, 34, 32, and 30. So here I have 44, and the 44 is not able to properly wet the surface. Now we are going down to 42, and you can see the ink is not working as nicely. And here I have 40, and you can see ink is shrinking again. Now let's go to 38. I see it is working much better. So we have 38. This is 38. Let's go down to 36. So don't worry about the color. It's the ability of the ink to wet. So these ink are getting older. So that's why there is some loss of pigment and the effect on wettability. So actually what I'm seeing in this case, inks with surface tension around 38 and below that are somewhat working okay. So I'm getting a feeling it might have surface tension somewhere close around 38 dynes per centimeter, or around that number.
The first step in the priming process is the corona treatment. A corona treatment increases the surface energy of a substrate to improve wettability and adhesion of inks, coatings, and adhesives. To determine if a corona treatment is necessary for a particular substrate, you first need to determine the dyne level of that substrate using Dyne pens. The optimal dyne level is 40 or 41,